All right. Hello, everybody. Let's keep this in the corner. Welcome to my second stream for Mechanical March. Um, I have been sick for the last couple of days, so apologies if I'm speaking a little slowly. And I think I might keep this stream a little shorter. Maybe I'm not going to do a full hour, but today's plan is to go over the exercise binary search, and I think we'll be able to do that together. Um, yeah, last time I gave an introduction to Rust and how to set up your environment. So for now, I'm just gonna jump straight into the exercise. And again, any questions you may have, feel free to put them in the Twitch chat. Um, Now, what is binary search? It is an algorithm to efficiently find elements in an array with the condition that the elements in the array must already be sorted, right? So in this example right here, we're looking at numbers. So the example states we have an array 4, 8, 12, 16, and so forth, and we're looking for the number 23. And with binary search, what you do is you pick the middle element of the array. In this case, that is 16. So we start by comparing 23 and 16. And 23 is greater than 16. So because we know that the array is sorted and 23 is greater than 16, we know that the entire left half of the array must contain elements smaller than 16, smaller than or equal. Therefore, we can throw away this entire half. And by using this method until, yes, we're doing Rust today. I'm going to do all of the 5 exercises in Rust for the entire month. Again, so because we know 16 is smaller than 23, we can throw away the left half of the array. And by using this method iteratively, we can very quickly shrink the size of the array that we need to search and get to the answer quickly. So let's jump right in. There are a few more hints down here in case you've already solved it yourself. These are very valuable. And I went over the exercise a little earlier and I saw that there are actually some additional tests which has an additional challenge to make your solution more generic. And I noticed that I haven't actually done that. So maybe we'll do that together and it'll actually be a new thing that I have done before. Right. So the interface is pretty simple. We got, is that big enough? Maybe I'll make it a little bigger. I think that should be fine. So, um, the interface is simple. We've got a method find, an array. Actually, it's a slice in this case, but doesn't matter, right? We get an array of numbers and a key, which is the number that we need to find. And what we need to return is option usize. So meaning if we didn't find anything, we're going to return none. And if we did find something, we're going to return a usize, which is the type used in Rust for indexes. So we're going to return the index of the element we find. There are a couple different approaches one could take here. I think I'm going to start with the most primitive, you could say, the most simple, straightforward, imperative way. The second most obvious approach would be to use recursion, which you may have done before if you solved this exercise with a functional language. But we're going to solve with an imperative approach, I think. So in order to do that, we need to remember the subslice of the array that we haven't looked at yet, right? So if we throw away the left side, we need to remember that we start for the next iteration with the right side. And to do that, I'm gonna initialize a variable left and right. And for now, those are just gonna be, left is just gonna be the first index in the array, and right would be the first index that's not part of the array anymore. And at some point we're going to have to loop, right? And of course, in the iteration, we need to stop iterating if the array is getting too small. But we might get away with not doing an if statement here. Let's just leave it for now, and we might come back and remove it later. So that would be if left. Let's say if right is greater than left, right? So if the difference between right and left, if that is smaller, say smaller than or equal to 1, so the size of the subslice we're looking at, smaller than 1, smaller or equal, then we know we can stop. But we also need to figure out if the last element we're looking at is actually the one we're looking for. So in that case, we would look into the array. If array.left, if that is actually equal to our key, then we would return sum, and the index of that would be left. And else we return none, right? And we're not expecting to get to really get outside of this loop. So let's just say that this part is unreachable. The reachable macro is just basically the same as, there are a few macros in Rust that basically do the same thing. Among them are unreachable, panic, to do, and all of these, what they will do is just panic, abort the program, basically stop the program. And the difference between them is first of all, the error message that's going to be printed looks a little different. But also the purpose is just for the programmer to be able to search for these macros in the source code. So let's say you don't know what to do, you don't know how to improve your code base, maybe you'll just search for to do for any lines of code that you may have left in the past, which still need some work. So here we're just saying, I'm not expecting this part of the program to be reachable at all. So if this line of code is reached, that's a mistake on my side, a mistake by the programmer. So now we covered the condition if the array is small enough. And now if the array is bigger than at least one element, we're gonna have a look at the middle element. So for now, let's just set that to the middle index. And what is the middle index, right? So the middle, let's also define the size of, or maybe the length of the array we're looking at right now. So that would be right minus left. That is the length of the slice we're looking at. And we can replace that here. So the middle element would be the index of the left index, and we would add to that half of the length, right? Now in Rust, the division operator truncate rounds down, as is the case with many languages. So what we have to consider here is what happens to array slices of uneven or even size, right? So if the length is some even number, maybe I'll put a little example here in code, right? So 1, 2, 3, 4. So let's say these are our arrays. One has an uneven number and one has an even number. So this one has size 3, and assuming the left is just 0, length divided by 2 would be 1. So the index of 0 plus 1 would give us index 1. So that works for arrays of uneven size. It hits exactly the middle element, which is what we want. But what happens for arrays with even number of elements? The length will be 4 in this case, divided by 2 is 2. And assuming we start at 0, that would give us index 2, which is, well, not the middle element exactly, because there is no exact middle element, but it's 1 to the right of that. And that'll work, but it's just good to keep this in mind. If there's no exact middle element, we're going to look at the one a little bit to the right of that. So now we have the index of the middle element, and until now the program is looking kind of ugly in my opinion, but we'll get to refactoring later. Let's try to do something that's not extremely ugly. We're going to compare the key to the middle element, right? So yes, that is the function that I want. Now, of course, there are the operators in Rust, right? Key smaller than array middle. We could do something like this, but this just gives us, this just returns a Boolean expression. And a really nice way to do it is use the compare function, because this gives us, in return, this gives us a type ordering, which is an enum with 3 elements, less than, equal to, or greater, which means that we can match on the value on these enum variants. Great tip for people using Visual Studio Code. I'm sure other editors have this feature as well, right? If you hit Control dot, there are some quick actions, and Rust Analyzer can fill your match statements with all the possible match arms. Now, the absolute path here is did CMP ordering. I find this a little ugly. So again, Control dot, I'm going to import ordering from the standard library. Now, I like this quite a bit, right? So we're comparing the key with the middle element, and we have 3 match arms for the 3 cases. So let's first of all consider the equal case, because that one's easy. because it means we have found our element. So we can just return sum and middle, because that will be the index of the thing. Telling me unreachable. Oh, that's probably because of the to-do here. And I need to put a reference here. Because for comparison, we don't need to consume a value, we only need to borrow it. That's why we need the reference here. So, what are we doing in the case of less, right? So at this point, we know that the key is less than the middle element, which means that we need to look at the left half for the next iteration, and we can throw away the right half, in which case the left actually stays the left array index stays the same, but we need to move the right index like inwards to the middle. So here we can say the new right is going to be middle. And of course, in Rust, variables are immutable by default. So let's change these two to mutable. We'll need left to be mutable as well. And by setting right to middle, we're just making sure that in the next iteration, we're looking at the left half of the array. And for the greater case, we need to do the opposite, which is move the left pointer inwards toward the middle. And actually, since we already looked at middle, we don't need to consider, we can actually go one further. So let's quickly consider why we don't add one here, but we do add one here, right? So the left index and the right index are a little different in the sense that the right index, it's starting at length. So the length of the array is actually not a valid index. And it's just one outside of the bound. However, left starts at 0, which is a valid index. And we're going to try to uphold that variant, meaning that right is just one more than the bound of the array we want to look at. So in this case, middle, we don't want to look at. Middle is just one more than what we need to look at. But in the case of left, we are going to look at left itself, and we don't need to look at middle. So we can add one here. I hope that's clear for people who are not familiar with binary search. Right, I think we might want to run the tests for now. And I'm very surprised that I'm being told this is unreachable. I mean, I know that this is unreachable, but how does Rust know? That is very interesting. Any code following this expression is unreachable. So how does it know? I'm almost thinking that I made a mistake here, because the reason this is unreachable is we're starting at some length, and in these two match arms, the length is shrinking all of the time, and we do have some condition here where if the length gets small enough, we're going to break out of the loop. But I'm very surprised that Rust would be able to figure this out. Let's get rid of this. Let's just run the tests. Yeah, so something's not right. That's what I could have guessed. Let's see, nothing is included in an empty array. Oh, the empty array case. Let's actually just copy this real quick. Let's look at the test cases. Yeah, I probably didn't handle that very well, the empty array. Um, yes, sure. So the empty array, we would look at that, go in here, and it would try to index into the empty array. And I suppose that would result in a panic. Yes, panicked index out of bounds. Exactly. So for now, because we are doing the primitive ugly version, let's just go ahead and do a little check for that, right? Ah, yes. And Clippy, I think this is Clippy is telling me to use the special method is empty. Let's see. So this is passing. The tests are passing, but I am incredibly surprised that Russ is able to figure out that we're not going to reach this. I'm very surprised by this. Shocking. All right, so let's just get rid of this, I guess. Um, and this is working. Let's just, I do want to do a little commit of that just so we can step through the diff later if we want to. So let's start refactoring that a little bit and make this a little nicer, a little rustier. Um, First of all, what we're doing here is we're doing index arithmetic manually, and this can be error prone. So I remember to do this, but I may have forgotten things like that. I actually did make a mistake here by indexing in zero arrays. So what I would rather do is just operate on slices directly and take subslices, right? So let's store the subslice that we are currently looking at. Let's actually store that directly in a variable. And that will obviously start at array. And let's say I don't want the variables left and right anymore. I don't want to have these anymore. So the compiler is now helping us out here. The length, we don't need to read this anymore. This would just be, let's give this a little better name. So this is our temporary slice. The length would just be temporary slice dot length, right? So, and if the length, I think we might actually get rid of that as well and replace those with the function calls directly. So and because we're at any point in time only looking at like the actual subslice that we're looking at, we can index with 0 right here. But this is a problem, right? This is the moment where we kind of need to know at which offset the temporary slice is relative to the array. So we might actually have to store to keep track of that. It's not going to be completely without index arithmetic in that case. Let's store the offset and put that in here. And the middle index is also going to be a little easier to calculate. We can get rid of left. And this should work. And what we need to fix now is instead of mutating these indexes, we need to actually make the subslice smaller. And what we can do for that is we reassign a temporary slice and we take a subslice of that one. So this is the basic syntax to do that. We're indexing with the little range operator, and this is the full range, meaning we're just taking the entire subslice. And we need to add the reference here because it's just borrowed the slice. Question from the chat, where can I get the schedule for each track, like CPP or Rust? I don't think there are different schedules for different tracks. If you want to look at only one language specifically, you'll just have to look at the entire schedule and figure it out on your own, which languages you're interested in. I think on the Exercism dashboard, if I'm not mistaken, there is schedules right here. I think they, yeah, it doesn't always say which language it is. So I guess I can't help you with that. But also it might be that, I mean, looking at the title, it might as well be that this person is going to stream just the exercise and in different languages at the same time, right? Maybe that person's going to stream the language in CPP and Rust and Zig and VLang. I don't know. That could be a fun stream. So yeah, I'm sorry, I don't think that exists. So this is the basic syntax of subslicing, and now we need to specify the actual slice. In the case where we need to drop the right half, we start at 0, which we can just leave off, and the middle index is the last index. So this is an exclusive range, meaning that the middle index is not going to be included, which is what we want. And in the other case, we want to start at middle plus 1. Middle plus 1 should be the first element of the subslice. And that's looking good. And what we should not forget is to update the offset, right? We should add to the offset middle, and I suppose also 1. I think so, yes. So to keep the offset up to date. Let's see if I made any mistakes. I did make a mistake. There is a test case, and I didn't find it here. So let's have a quick look which test case that is. It's supposed to find 6. It's right in the middle, and we're not finding it. No, we're supposed to find 11. And that can't be right. Oh, okay, 6 is the index. So we're not finding the last element. Some stream titles. Yeah, got it. So we're not finding the last element. Chat, feel free to help me out if you know what I did wrong. Do we need, I don't think we don't need to update the offset here. And if we're not finding the rightmost element in the array, then my intuition would be that something is wrong here. I mean, we could try it like this, but I'm not sure this is going to fix it. Yeah, the mistake is something else. You know what? I think it's time to do some debugging. Um, let's set a breakpoint and debug this test case. Right, let's get rid of that. And that stuff is probably not interesting. Let's jump through a few steps. And as we can see here, this is the array that was passed as an argument. And here we have a subslice of that, which goes until 11 for now. And the middle element of that is index 3. That is correct. And the middle element would be 6, but 11 is greater than 6, so we're in the correct place right here. So this is going to be interesting, right? The new temporary slice, this is looking correct to me, right? We compared to 6, and we dropped 6 from the temporary slice. And we should be adding 4 to the offset, because the index of 8 is 4. And the offset is 4, so this is looking okay until now. And for the next, we're going to be looking at 9, I suppose. The middle element should be 9. And again, this is looking good. And we're adding 2 to the offset. Offset 6 is looking great until now. And now we're getting to the end condition. Oh, okay. Of course. That is a silly mistake. As you can see, I'm still indexing into array, which is always just going to be the first element of that array, but we need to index into the actual subslice. Oh, that's the wrong terminal. Let's get out of here. That hopefully should have fixed it. No, we still have mistakes. Go away. Let's see. This is annoying. There we go. That's better. What else? What else? What else did we do wrong? Finds a value in an array of even length and odd length. Let's try the odd length for now. So, and we are looking for 144, and we should find that. Yeah, this looks like it should work. Let's debug that. Don't this. And 144. This is a large array that we're looking at. Let's put that into temporary slice. Let's look at that. All right, so there's mistake already happened right here. That's interesting. No, there's our element right here. 144, offset 7. So yeah, this is looking good. 9 is 144, and taking away 7, 2, 4, 144. Let's keep going. At this point, it should be in the left half of the array. This is oh, okay, same mistake here. That's not good. I also indexed into the array here. Maybe it would have actually been smarter to use shadowing in this case, right? I could have shadowed the variable array entirely, which would have prevented this problem, and Rust does allow this. But let's go back from that, because hopefully that is the last error of this kind that I made. Yeah, I'm not seeing any more arrays. And let's try the tests again. It's not the terminal I want. Still another mistake. This is proving to be more difficult for me than I thought to get it right. First solution was ugly, but it was correct. All right, let's do it again. Actually, what are we looking for exactly? I didn't even check. We're looking for the element 21 in this array right here. Okay. Let's jump through. This is already the middle element, right? So we got 5 elements here. And no. It's 12 elements, and so it's just on the left side. Which means it's going to be less, right? And we're taking the subslice of that. And now it's at the rightmost edge. This is looking good. Offset didn't change. This time it's greater. And we're taking away. Ooh. What just happened? Is that correct? Is that correct? I want to look at that again. Because we go through that once, and here, how many elements do we have? We have 6 elements. The middle element we're going to look at is 8. Yeah, no, I think it looks good. So we're going to look at 8. 21 is greater. So we're just going to look at 13 and 21. And the offset of that is going to be 4. Yeah, that looks good. And now, this should actually be the element that we're looking for. Oh yeah, I see. Yeah, that's also a mistake. There we go. Here we made the mistake of not adding our offset. All right. Found 3 bugs in a short amount of time. All right, so we fixed that as well. That was a fun little refactoring, and we made a couple mistakes along the way. But that's okay. I think we should be able. Let's refactor it. Let's do a little commit. And I think I want to get rid of this if statement right here. And let's say maybe we can also get rid of this right here. So here I'm doing smaller or equal to 1. I think we do need to do that because it's possible that we're jumping from an array size of 2 to an array size of 0. If we look at this example right here, the middle element, this is going to be chosen as the middle element. And if the number we're looking for is 3, for example, we're going to execute the greater than arm, which means the next subslice we're looking at is just going to be empty. So we kind of need to keep looking for 0-sized slices, but maybe we can get away with not doing the equality check on size 1, because If the array is size 1, then we can just, I think the rest should work just like before, because the length is going to be 1 divided by 2 is 0, and then we're just indexing at 0, which is the first element, so that should work. I think in that case, I just want to say is empty here, and if we are empty, then we're going to return none. That's not right. So if we're empty, we return none. And actually, this might allow us to get rid of this. Maybe, I don't know, possibly. Yeah, I think so. We can get rid of that as well. Let's make sure I didn't make any more mistakes. Um, that one's working, yes. And maybe we can get rid of this as well. All right, tests are passing as well. So, did a little more refactoring, and the solution is getting kind of concise. Now, this is looking all right. There are two options what we could do right now. One option being taking a completely different approach and doing recursion, but I think what I would rather do is the other challenge, the additional challenge, because if we look right here, we have some additional bonus challenges. If we run cargo test features generic, and these are actually not passing right now. I'm pretty sure of that. Oh, it's not what I want. Let's see. If we run cargo next test features generic, yes, these test cases are not compiling right now. And the challenge is this. Let's look at the description. Yeah, saying it right here. Right now it's operating on a slice, our function, and one challenge is to make it work on both on slices as well as vectors and arrays. Additionally, right now it's only working on numbers, and the challenge is to make it work on any type which is comparable. And let's just take a quick look at the test cases to get an idea of what that means, right? So here in the test cases, function is always called with a slice of numbers. The fact that it's a slice, you can recognize that by the ampersand right here. It's borrowed. And here we got a test case with an array. It doesn't have an ampersand, so this is an owned stack allocated array. In this test case, we have a vector, which is also owned, but heap allocated and dynamically sized. And lastly, in the third test case, we have also an array. However, this time the elements are string slices, instead of numbers. And I do recommend trying this yourself because the exercise it's done very well. You have some pretty good help down here. It's actually telling us to use the ORD trait and the asref trait. This links to the standard library. And the ORD trait is basically just a trait for types which have a total order. And if we jump into the exercise, this method I used right here, CMP, is actually a method from this trait, exactly, from the ORD trait. Jumping back in the documentation, the asref trait, this one's a little more interesting. The asref trait is implemented, yeah, we're probably not going to have time to read everything here, but the asref trait means that a certain type can be used as a reference to another type. What does that mean? In our case, we have two different types to compare. We want to compare numbers and we want to compare strings. And both of these types implement the ORed trait. So we can use the ORed trait for the elements of this array. And the other challenge is that we have, the container type can be a slice, an array, or a vector. And the point is that arrays and vectors can be treated as references, like the name of the trait says, as ref to a slice. So let's try to do that. The syntax for these generics might be new to some of you. So in the function definition in angle brackets, we're defining two type parameters, t and u. And actually, let's give these better names. TLM and T container. Something like that, right? I think in Rust source code, usually what you'll see is just one letter generic parameters. And I think it's fine most of the case, but for now, I'm gonna choose a little more descriptive names. And I'm jumping the gun here a little bit. Instead of taking a slice of numbers, we would then, we could say we're taking a slice of the type of the element, and the key is also the type of the element. But actually we need to go further and say this entire thing, the entire array is just this generic container type, right? And now we're getting the type errors because Rust doesn't know anything about these generic type parameters. So for example, here it's telling me that this generic container type, it doesn't have a method is empty. Now, all three types that we need to solve this exercise for, slices, arrays, and vectors, all three of them do have an isEmpty type, an isEmpty method, but we need to tell this to the compiler somehow. And the way to do this is by using these constraints. So let's start with the container for now. Let's say the container, that is actually a slice. Can I write it like this? I'm not sure if I can write it like this. I cannot. So let's start with the element in that case. TLM. Let's put a constraint in TLM, and we're going to say it has a constraint ORed, so we must be able to compare these, right? Let's check what happens if we take this away, because yes, exactly. If we look at this error message right here, it's telling us that the type TLM doesn't have a compare method. However, if we add this constraint, this generic constraint right here, the compiler is happy with this because it knows any type which implements the ORed trait has a method compare. Therefore, this compiles. Now, the rest of the errors we're getting is related to the fact that it doesn't know, the compiler doesn't know that tcontainer is a slice-like thing. Slice, array, vector, something like that. So we need to put another constraint on tcontainer, and the exercise instructions already told us which constraint that is. and that is the asref trait. But the asref trait has a generic parameter as well. So as a reference to type T, um, if we write it like this, then we're saying T container can be treated as a reference to the type TLM. But that doesn't actually work because TLM itself doesn't have an isEmpty method itself. And the thing that we need to do is add these square brackets. Oh, this isn't even working yet. That's surprising. So what we're saying here is that T container can be treated as a reference to a slice with elements of type TLM. And I think this should compile. I'm very surprised that it's not. Let's see. No method is empty on type T container. The following trait defines an item. Perhaps you need to restrict type parameter with exact size iterator. I'm very surprised that this does not compile. Let's see, what kind of is it? What type does this have? Yeah, it has type T container. Ah, yes, of course. So this is, yeah. If we look at what kind of methods are actually available on TempSlice itself, um, we do have to call asref first because before we can actually treat it as a reference to such a slice. So in that case, we're just going to go ahead and add asref here. Now this compiles beautiful. So I hope that's this is intuitively clear what this is doing. So we're not saying that it is a slice to T of elements TLM here with this trait. We're just saying it can be treated as. But if we do that, we still need to add this one method call asref to say that we actually do want to treat it as a reference to a slice of TLM. And as we can see, the type of array is T container. And what we're getting back with temp slice is just a plain slice to elements of TLM. And the rest of the function remains exactly the same. So we just added these generic type parameters, changed the types of our arguments, added constraints with the correct interfaces, and we had to add a little method call right here to actually get the reference to a slice. I think so. The regular tests are all obviously still passing, but now if we run the generic tests as well, this one's passing as well. So I think that should be enough for today. I did in fact almost stream for an hour. So I hope the stream was bearable with my sick voice. And I hope especially the last part with the generics was interesting to you guys. And yeah, let's call it a day. I'm going to be streaming again next week, hopefully healthy again. Wednesday evening, 7 p.m. Central European Time. Hope you have a good night.